Hi, welcome back. In this video, we will see various types of operating system. Guys, at the initial stages of developing operating system, it was named as batch operating system. Guys, batch operating system will work or will perform only one task at a time. How it will perform only one task means, generally we are going to have memory. In the memory, we are having an operating system and we are going to have various number of jobs are there. Job 1, job 2, job 3 and so on. So here the task of the operating system is to load one of the job from secondary storage device to the main memory, or we can say it as RAM, right? Based upon the scheduling, assume that job J1 is loaded, and after certain point of time, if J1 requires some kind of IO operation, something like, for example, it is meant for requesting some kind of printing, then at that time job J1 will be in printing state. Now what about the CPU here? CPU is in idle state. Why CPU is in idle state? Because there are no jobs, right? Even there are no jobs, operating system can't load the another job to here to make the CPU busy. It is because of that is the property or the characteristics of batch operating system. This is the reason we can say it will perform only one task at a time, right? If you want to have more clarity, let me take an example. Assume that there will be a program which contains some 1 lakh lines of code, line number 1, line number 2 and so on, some 50,000 one line and so on, 1 lakh lines of code is there. Assume that this program, if it is under CPU, we can call it as a J1 process. It has done all these 50,000 lines of code, right, at the CPU. Once it reaches to 50,001 line code, the code here written is related to printing operation. So CPU will switch from the CPU to hand over it to the printing state, right? When switch from hand over to the printing state, now assume that this printing requires some 100 nanoseconds, right? So now J1 will be here. When J1 will be here, meanwhile this 100 nanoseconds of time, CPU is going to be completely idle because of it is batch operating system, right? Means batch operating system will only perform one task at a time. Once a particular task completely done, then only other job is going to be do, right? So means after 100 nanoseconds again J1 will be comes to the CPU and it will perform all the remaining 49,990 lines of code and it will exit from this one. Then the other job will be loaded like something J3. This is what the general characteristics of batch operating system, right? Yes, fine. So if you are able to understood here, what might be the drawbacks of batch operating system? One will be CPU idle is more, right? And one more thing is throughput is going to be less, guys. Throughput is less. So generally throughput means number of jobs completed per unit of time. We can call it as throughput. For example, per second, if I completed 10 jobs, the throughput is 10. Like that we can able to calculate. So as here the CPU is idle and no other job is working, so obviously throughput is going to be decreased or not? That's the reason these are the two drawbacks of batch operating system. Okay, so if you give certain example for this one, the example can be which is related to IBM OS 2 guys. And anyhow, this was an outdated OM, outdated operating system. Okay, fine. Let's take the second one, that is multi-programming operating system. Okay, so in multi-programming operating system, we can able to perform multiple tasks at a time. Means when a particular job is loaded, assume that OS is there, J1, J2 and so on are there. When a particular job J1 is working on the CPU, and if it is requesting for some kind of IO operation like printing, then J1 will be shifted to IO operation. As here CPU is not having any work, the other job might be loaded which is requested by some other process, something like J2. Right? Means when the particular job is leaving the CPU to perform certain kind of IO operation, we are not going to make the CPU idle here. CPU idle, right? The best example for this one is all kind of operating systems what we are trying to work now. Windows, Linux, Ubuntu, all the things will become under this kind of thing. So here in multi-programming operating system, we can able to switch from one job to another job, right? We can say that switching or multiplexing among the programs that we can call it as multi-programming operating systems, right? So generally here, compared to batch operating system, CPU idle is going to be decreased and throughput is going to be increased, right? And we have other type of operating systems are there, like we can say it as multitasking operating system, or in other terminology we can say time sharing operating systems. In multitasking operating system or in time sharing operating system, we are going to have a terminology called time quantum guys, right? So before going to explain the keyword of time quantum, let me draw first the structure, right? You know, OS reside in the memory and job 1, job 2 and so on, n number of jobs are there. When a particular job is loaded with operating system into the CPU like J1, and if it requests for some kind of IO operation that will be loaded, and as here the CPU is idle, some other process will be loaded by the operating system. This is generally multi-program is going to be happen. But here the time quantum is something like, suppose for example, I will give clear example. Job J1 requires for 5 nanoseconds to execute. Job J2 is requiring 100 nanoseconds to execute. Job 3 is requesting for 1 nanosecond to execute. Now what will happen? Assume that there are no IO operation. No IO. Now according to this scenario, if I remove this one, what will happen? According to multi-programming, J1 loaded and complete its execution for 5 nanoseconds, then J1 comes out, then J2 will enter into here and execute 100 nanoseconds, then it will come out, then J3 will enter here and it complete its task. J3 will be done. So in order to complete the task of J3, how many nanoseconds it has taken? So first J1 has to done, J2 has to done, then J3. So total it's going to take 106 nanoseconds in order to complete the task of J3. Means it has to wait for I can say it has to wait for 105 nanoseconds wait and 1 nanoseconds for execution of its task. That's it, right? This is what in multi-programming is happening. Multi-programming is happening. But right, if you are able to observe the thing here, J3 is having the less time. Even it is having the less time, it has to wait for more time according to the process order, right? So I can say that starvation is going to be more in multi-programming environment. So to overcome that, they come up with time sharing operating system where each and every process having some kind of time quantum. For example, J1, J2, J3. J1 requires 5 nanoseconds, J2 requires 100 nanoseconds, J3 requires 1 nanosecond. When operating system is loaded J1 into the CPU, after 2 nanoseconds, means assume that time quantum will be 2 nanoseconds. It can be any time. There is no worry. But I am assuming that 2 nanoseconds is time quantum, meaning that for each and every process, each process, it will allocate only for 2 nanoseconds. After completing 2 nanoseconds, it has to come out and it has to give chance to the next one. So for J2, it has to give the next chance to J2, and it has to come out and give chance to J3, and as J3 requires 1 nanosecond, it will complete in 1 nanosecond. So in order to complete the task of J3, how many nanoseconds it will require? 5 nanoseconds. Among these 5 nanoseconds, 4 nanoseconds it has to wait and 1 nanosecond it has to execute, right? So which means that here it is going to perform some kind of preemption. Preemption means forcefully thrown from the CPU to the memory and load another job into the CPU, right? Once this task is done, then again chance will be given to J1 for 2 nanoseconds, then J2, then J1, J2, and so on. This process is going to be repeated until its task is going to be completed, right? So the advantage of this multitask environment is where user interaction will be more, right? Somewhere if you are trying to work your system, something like listening of songs while playing the game or while writing the code, all the things will be done parallel, right? That will becomes under time sharing operating system. But have you thought that they are working one after the other? No, the system will do like that, right? Because it is in nanoseconds. As it is in nanoseconds, you cannot able to grasp it, how it is changing from one process to another process. Internally, it actually doing first process P1, then process P2, then process P3, and so on. But we are thinking that all P1, P2, P3 are doing parallelly, but it is not the correct one. Because of these are working sequentially in fraction of nanoseconds, we are assuming that it is kind of a parallel thing. We are believing, but it is not the thing. They are going to be sequential only. Next kind of operating system, something like multi-processor operating system. In multi-processor operating systems, we are having more than one CPU. I can say we are having multiple CPUs. I mean, more than one CPUs are existed, so that we can able to perform the task within the less time, right? If we take a single system, it is having CPU 1, CPU 2, CPU 3, all are connected to the same memory. As it is connected, it is having only single system, right? So which means that in single system we are having multiple CPUs. When we are having multiple CPUs in the single system, assume that I am having J1, J2, J3 are the tasks. J1 will be handled by CPU1, J2 will be handled by CPU2 and J3 will be handled by CPU3. Then how much time it is going to take to complete the task of J3? It will take only 1 nanosecond. Am I right? It will take 5, it will take 100 as per this example, and J3 will be 1 nanosecond, right? So as all are working parallelly, J3 will complete in 1 nanosecond. So can you observe that is multiprocessor operating system is far better than multitasking operating system or not? Yes. Fine. So that is the advantage of multiprocessor operating system. Right? Yes. Fine. So if you look into the advantage of this one is obviously as number of jobs are going to be completed heavily, throughput is going to be definitely increases. Right? And what about the reliability of the system is increases. If suppose for example J2 failed, the task of J2, the task of CPU2 which has to done for J2 will be handed over by either CPU1 or CPU3. So is the reliability is increasing or not? Yes. And one more thing will be let's say it is economical, meaning that cost will be less, guys. Why cost will be less? As single system with 3-piece CPUs is less cost compared to 3 systems with 3 CPUs or not. Yes. That is where it is economical. Hope you understood clearly, guys. Yes. Next kind of operating system, one is a real-time operating system. Guys, so this real-time operating system are a kind of systems which are strictly time bound, guys, which means whatever the task that we have given, all the tasks should be completed with exact time. I can say that there should not be any delay in the instruction. There should not be any delay in the instructions. If we are going to perform some kind of delay, there will be definitely huge loss may happen. That kind of operating system we call it as real-time operating system. Means every instructions what we are going to give has to be completed in the given time. We can call it as there should not be any delay. So in general, these will be classified into 2 types. One is hard real-time operating systems, and another one is soft real-time operating systems. Hard real-time operating systems, something like if we observe if there is any minor delay, definitely there will be a kind of which we can say huge loss will exist. For example, if I take the example, you will get clear idea. If I take something like missile systems, right? So actually we have set certain target that has to be perfectly done after 2 nanoseconds. If it is not done after 2 nanoseconds, means after 3 nanoseconds it has done. If after 3 nanoseconds it has done, where it will move? It will move from beyond the target point, means it will blast at some other location, right? So obviously this is going to be a huge loss or not for us or not. Yes. That is the reason this will become under hard real-time operating system. Something like satellite communications. When the rocket launch is happening, the time is crucial, right? At what point it has to enter into the orbit, all those things will be exactly calculated. If the delay happens, definitely it's going to be blast. there will be huge loss. Crores of money is going to be lost, right? So coming to soft real-time operating systems, even if there might be some delay, there will not be, definitely there will be a loss, but there will not be huge loss. That will be comes under soft real-time operating systems, guys. Right? For example, let's take any kind of banking sector. Banking sector, where if sometime it will be delayed, there is no problem at all. Am I right? Yes. This kind of things will become under real-time operating systems, and you can observe some kind of operating systems called distributed operating systems, right? So these distributed operating systems, if you want to make same interface for all kind of users, same interface for all users, then you can go with the distributed operating system. Means if the resources, whatever the resources are there, those resources are in general independent, and they are going to be controlled by one operating system. That is comes under distributed operating system. Means this is a kind of an operating system which can handle various kind of resources what are available all over the location, right? Something like client to client communication, or peer-to-peer communication, client-server communication. Those are various kind of things are there. But as we are trying to discuss various types of operating system, just go with this point. Okay. Next one, we can have mobile operating systems, right? So these mobile operating systems are designed to power various kind of smartphones. Am I right? For small handheld devices like smartphones, wearable devices, and something like tablets, small device, right? For all the things, we are going to use this kind of operating system. Like if I say for smartphone, the Android operating system is there. For let me take any kind of wearable device like smartwatch, something. If I go with both OS, both smartwatches, we can have an operating system called Crest plus operating system is there. Like that, for small handheld devices, they come up with various kind of operating systems, right? Not only these 7 types of operating systems, we are going to have many kind of other operating systems also, but these are the main important operating kind of systems, right? Hope you understood clearly, guys.